Hi, so I'm doing a quick revision question on binomial theorem, and you might be aware of a different notation. Perhaps this could be written as x choose 2 plus x choose 3 minus 4x is equal to 0. So that is what we need to calculate, and this is obviously, if you are given this, then you should know that it means n factorial over r factorial multiplied by n minus r factorial. Okay, so I'm going to use the same concept, and it's important they are saying that x is a positive integer. So this is the same then as x factorial over, so here I can have 2 factorial, and then I have x minus 2 factorial, and then should be added by x factorial over, and then that gives you 3 factorial, and then you have x minus 3 factorial minus 4x is equal to 0. Now, on top, I believe that you know that this becomes, if you have a number like, for example, if you have a number like, let's say you have 5 factorial is the same as 5 times 4 times 3 times 2 times 1, or you can have 5 times, in the bracket, 5 minus 1 times 5 minus 2, okay, times, until you get that. So you can see this is another way of writing 4 and another way of writing 3. Okay, so I'm going to use that. So I'm going to have just the place where I have 5, I will put x's there. Okay, so on top then, so that it can correspond with the denominator, so that I can sort of do taking out common factor. This is x factorial, and then this is going to be x minus 1. No, that's not x factorial, but that will be x times x minus 1 times x minus 2. That's where I'm going to end, okay, all over. Now 2 factorial is nothing but 2 times 1 times x minus 2 factorial. The same here, I'm going to have x minus 1, x minus 2, x minus 3 factorial as well, and so that the denominators, the x minus 3 factorial is common, and this is 3 times 2 times 1, and then x minus 3 factorial. Don't forget the minus 4x equals to 0 over there. Now what we can do is we can cancel this and cancel that, cancel this and cancel that, and obviously this here becomes a 2 and this one here becomes a 6. Right, so if I have to just clean that up, I'm going to have x and then x minus 1 plus, this is all over 2, of course. Then I have got here x, then x minus 1, x minus 2, and this is all over 6, of course, minus 4x is equal to 0. I think you can see that somehow we'll end up with an equation with quadratic, and then we'll be solving. So cleaning this up here, obviously you are going to multiply the whole of this term by 6. Okay, so you want to clear the fractions here. So 2 times 6, of course, if you look at the LCM of 2 and 6, this number is over 1, so the LCM is going to be 6. So you multiply here by 3, you obviously multiply here by 1, and you multiply here by 6. So you're going to multiply that by 3, this one is going to be multiplied by 1, and you're going to multiply here by 6 as well. So of course you can do that the same on the other side. It will just give you 0. So at the end of the day, I have everything over the same denominator. So I have got 3, then x, and I have x minus 1 plus well, I can maybe for now I can remove that multiplication on that side, so I can just continue here. Then I have got x, and then I have got x minus 1 times x minus 2. Well, all of this, as I said, is now all over 6 is equal to 0. So of course there's that minus 4x. My goodness gracious, let's just bring it in here. So you have got the minus 24 now. This is 24x. And I hope you can see that now. That is 4 times 6 is 24. Okay. Right. Multiplying throughout by 6 in order to clear the denominator. You have got 3 x minus 1 over here. Plus you have x. I'm going to do this. X minus 1. Put this one in square brackets for now. And minus 24x, just a little bit of algebra, play around with the algebra, just make sure that it's sound, you don't make mistakes. So on this side I have got 3x squared minus 3x. Well, I'm going to have plus x in here. Inside the bracket I am going to have, if you were to multiply, you're going to have this times that, which is x squared, that times that, which is minus 2x, minus x, and plus 2. Okay, so let's just clean up what we can so far. Before I do that, I'm going to have 3x, goodness gracious. I'm going to have, well, so here we go again. This is obviously going to give my things a lot of problems. I have to probably start over. I'll just close this. Never mind, you know, it's a little bit rusty. It's been a while. See if we can restore where we were. Of course, I have got 3x squared minus 3x. Here, I'm going to, maybe I should first just clean up what I have inside the bracket. I have got x squared minus 3x for like terms, plus 2 minus 24x, of course. Now, I will multiply throughout by that x there. So this is 3x squared minus 3x plus, so this is where I am. I'm going to multiply this over, that is going to be x cubed. I'm going to multiply this over, this is minus 3x squared. I'm going to multiply this over, that's obviously plus 2x minus 24x is equal to 0. Well, it's quite clear that you are going to be left with a number of things that cancel. This 3x squared and this one cancel. I'm going to have like terms here. So I have got minus 3x plus 2x, that is minus 1x minus 24. So I'm left with x cubed minus 25x, that equals to 0. Okay, that's what that will give you. Of course, you can take out the common factors. You have got x inside, and you have got x squared minus 25 is equal to 0, right? So x is equal to 0, or x squared minus 25 is equal to 0. Now, we're told, or let me just continue with this one here. So this one is the difference of two squares, x minus 5 or x plus 5, then they equal to 0. So you have got x equals to 5, or you have got x equals to negative 5. So you have got 3 solutions here, and that is not your final answer, because you were explicitly told that x should be a positive whole number, a positive integer. Therefore, the solution here, the solution we are looking for, is going to be x is equal to positive 5. So x equals to 5 is our final solution. So we're going to reject the other ones. Okay, so that was just a very quick question. Let's see if you will not sort of vitalize your work on binomial theorem.